Hello everyone, this is Vinay and today we are going to discuss some points about heat treatment of steel and only some points, not many. Generally, we use steels in many applications, like in everywhere we use steels nowadays. And for example, when let us take an example of our gates, gates and window frames. They are very strong because they need to withstand high temperature and heavy loads also. And if we hit a gate with a car, and it should withstand gate, not car. It obviously car will damage. If and Gate should be very hard. To increase the hardness of a material, heat treatment is done, and many other purpose also heat treatment is done. And when we come to the by the I mean, sorry, he- heat treatment process. It is a heating and cooling operation done for a metal to improve its internal stresses, internal structure, physical, mechanical, and chemical properties also. And heat when we in heat treatment process, time and temperature, these two are strictly noted because the if a temperature increases, the metal we know the metal will loses its physical properties, and by applying some force, it changes its shape into some other properties, required shape. And the temperature time is also strictly noted because it affects its grain size. In order to maintain the sufficient grain size, we need to know time and temperature properly. And these are stages of heat treatment process. The stage one, that is from A to B, and that is heating a metal from 0 to 723 degrees Celsius or above. Because that is our austenitic temperature. The temperature, and holding it for certain period of time, and then cooling rapid. And cooling operation is done in 3 to 4 ways, and we will see it now. And if we take a metal, we are heating it up to certain temperature, and the existing properties will wiped out. And cooling operation is done in 3 ways, and the other one is also there, that is tempering, and I did not mention over here because of no room. Aniline, normaling, hardening and tempering. Very slow cooling is called aniline, slow cooling is called normaling, and rapid cooling is called hardening. And we will see some examples of these processes. And very slow aniline, heating a metal up to certain temperature and maintaining up to certain uh, t- period of time, and then cooling inside a furnace, because inside furnace there will be no air. With the help of surroundings, the temperature of the furnace will be decreased, and the cooling operation, and the metal will be cooled, and that is called aniline. And normaling, it is cooled inside the, not inside the furnace, it, air. It is in air. It is directly exposed to air, or artificially applied some air to the metal. That is like by with the help of fans, coolers, etc. And rapid cooling. After heating a metal, and we are cooling it inside the, cool, throwing the metal inside the water or oil or salt water, etc. And tempering is heating a metal up to certain temperature and decreasing it by some cooling agents, and then increasing the temperature, and for after some time the cooling operation is done. And tempering operation is very important because the by these three processes, corrosion will be increased because the heating is done with the help of charcoal. Charcoal is not a good, it increases the carbon property, and with the increase of carbon property, corrosion takes place. By doing tempering process, the internal stresses develop after this hardening process. It removes the internal stresses, and it improves the grain size, and the temper and the metal will be used for long period of time. And now we see some examples of aniline and how the aniline is made, process is done. Look at this. First they took the metal inside this, inside the cube, which is in hexagonal shape. After heating, the lead is removed with the help of crane. It will be very heavy, and the temperature is inside the box is very high. We cannot directly touch the metal with our hands because the hand will be burned. With the help of crane, they are removing this metal. Now the metal is in red hot condition. We can see the color of the metal. It is very red. It is red, and they kept inside this furnace. This is a furnace box, and they kept it inside this. After that, they will close this furnace box with this lid, and the cooling is done inside the furnace, and it takes lot of time. And this is normaling, and as I said, normaling is slow cooling process. It is directly exposing the metal to, I mean, air. Here we see. Here they took charcoal in this one and hitting the. This is a metal. Here we can see this is a metal, and with the help of charcoal they are heating it. After reaching a certain temperature, the metal will be removed. See, the metal is, and again he is heating. Now we can see. With the help of this tongs, he removed this metal knife. He made knife, and he is heating the knife. Here, this is metal. This is metal. He placed the metal inside this, and you can see here. You need to note this. Here, sorry, once. Uh, Sorry. Now you see. Here the metal is Here the handle is not fully kept inside this, because if the handle is fully kept, this part is upper part of the knife is directly exposed to air, and it will be cooled faster than this lower part to and if we keep this metal outside this, it will be first the metal will be cooled in this area, and then the coolingness will be passed up to here, and it will be easier, it will be fast. These four properties are different because the of this grain size hardening. We'll see hardening. As I said, as I said, hardening is directly throwing the metal inside the water. I mean, quenched inside the water. Here, the metal is kept inside this and heating it up to Martin's austenitic temperature, that is 723 and it's above. Here, the metal is in red hot condition. He is taking out from this. He passes through the belt, and then now we can see. Internet is too slow because that's why it is loading. And now you can see the pulley is getting down, and the metal is quenched with water. It can be salt water or oil or normal water. The metal is quenched with water. And aniline these four properties are very important. Hard tempering, because I did not wrote here because of no room, and various heating sources. We can heat the metal in air, oil, salt bath. and cooling and salt water. Means boiling water. Best example. And the metal is kept inside the boiling water and heated. In air means by applying charcoal. Cooling media, it can be brine solution, so cold water, water plus soluble oil, oil, air, etc. Air can be artificial or natural, as I said. And objective, I mean importance of heat treatment process to relieve the internal structure. Internal stresses will be relieved and improves refining grain size. Uh, this is important one in this. I mean to refine the grain size, it is an important one in hardening the steels. It improves the mechanical properties and improve machinability. With the help of hammer, we can change any metal size and shape. It improves our mechanical property. Hardening and strengthening material improves electrical and mechanical properties. Improves weight resistance and corrosion resistance, as we know. Aniline is of four types: full process paradise stresses and hardening and normalizing are also of my three to four types. I did not mention over here because of no rule. And tempering is also of four types. Surface hardening and case hardening, where heat treatment processes are divided into two types: bulk, surface. Bulk means large, surface means small, for small one. And surface or case hardening, where these are of two types: diffusion and thermal process. Diffusion, this is not in our syllabus, but it is important to know. I mean, it is important, not not for exams, but to understand it. Diffusion means directly diffusing the metal with some other carbon containing chemical. Directly diffusion, it improves the mechanical property. And case hardening, uh, sorry, thermal process. Thermal means heat and process means sorry, thermal means heat and heating the metal with thermal process. Those are of two types: flame and induction. Flame means directly applying the flame to the metal, like we have gas cylinders in our home. By heating, I mean, with the help of flame, we can heat any object. In the same way, flame is used. Case depth. Case depth is means if it is a metal, the surface of the metal will be hardened and not complete metal inside this. It won't be hardened. Only for certain limit, hardening process takes place, and this is called case depth. And the next explanation is there. Thank you.